Top 25 HVAC Engineer Interview Questions and Answers. Preparing for an HVAC engineer interview means you need to show both technical knowledge and practical problem-solving ability. Employers want someone who understands heating, ventilation, air conditioning, refrigeration, equipment selection, troubleshooting, safety, energy efficiency, and maintenance planning. They also want to know how you communicate with clients, contractors, technicians, and project teams. In this guide, you will find 25 common HVAC engineer interview questions with strong sample answers. These answers are written to help you sound confident, professional, and job-ready, whether you are applying for a building services, facilities, maintenance, construction, or design engineering role. 1. Tell me about your experience as an HVAC engineer. I have experience working with HVAC systems including chillers, AHUS, FCUS, cooling towers, pumps, ductwork, ventilation systems, and control systems. My work has included system design, load calculations, equipment selection, preventative maintenance, troubleshooting, site inspections, and coordination with contractors and clients. I understand the importance of comfort, indoor air quality, energy efficiency, and safety. I also try to balance technical requirements with cost-effective solutions. My goal as an HVAC engineer is always to ensure reliable system performance and long-term operational efficiency. 2. What are the main responsibilities of an HVAC engineer? The main responsibilities of an HVAC engineer include designing, installing, testing, maintaining, and troubleshooting heating, ventilation, air conditioning, and refrigeration systems. An HVAC engineer must calculate cooling and heating loads, select suitable equipment, prepare technical drawings, inspect installation work, and ensure compliance with codes and standards. They also coordinate with architects, electrical engineers, civil teams, contractors, and facility managers. Another important responsibility is improving energy efficiency while maintaining comfort and air quality. Good documentation, safety awareness, and problem-solving skills are also essential. 3. How do you calculate cooling load for a building? To calculate cooling load, I consider several factors including building orientation, room size, wall and roof insulation, glass area, occupancy, lighting load, equipment heat gain, ventilation requirement, outdoor conditions, and desired indoor temperature. I may use software such as HAP, TRACE, or manual methods based on ASHRAE guidelines. The goal is to estimate the total sensible and latent heat load accurately. Correct cooling load calculation is very important because undersized equipment will not provide comfort, while oversized equipment wastes energy and may cause humidity problems. 4. What is the difference between an AHU and an FCU? An AHU, or air handling unit, is usually a larger unit that conditions and distributes air to multiple zones or large spaces through ductwork. It often includes filters, cooling coils, heating coils, fans, dampers, and sometimes humidifiers or heat recovery sections. An FCU, or fan coil unit, is smaller and usually serves a single room or small zone. It contains a fan and coil and may be connected to chilled water or hot water. AHUS are more common in central systems, while FCUS are used for zone-level control. 5. What is the purpose of ventilation in HVAC systems? Ventilation is used to bring fresh outdoor air into a building and remove stale, contaminated, or polluted indoor air. It helps maintain indoor air quality, controls odors, reduces carbon dioxide levels, and supports occupant health and comfort. Proper ventilation is especially important in offices, hospitals, malls, schools, kitchens, and industrial spaces. However, outdoor air also adds cooling or heating load, so it must be designed carefully. A good HVAC engineer balances fresh air requirements with energy efficiency, often using dampers, sensors, or heat recovery systems. 6. What is the difference between sensible heat and latent heat? Sensible heat is the heat that changes the temperature of air without changing its moisture content. For example, when air temperature rises from 24 degrees Celsius to 28 degrees Celsius, that is sensible heat gain. Latent heat is related to moisture in the air. It changes the humidity level without directly changing the dry bulb temperature. For example, removing water vapor from air through condensation on a cooling coil removes latent heat. In HVAC design, both sensible and latent loads are important for comfort, cooling performance, and humidity control. 7. How do you select HVAC equipment for a project? I select HVAC equipment based on cooling or heating load calculations, airflow requirements, project specifications, available space, energy efficiency, budget, noise limits, maintenance access, and site conditions. I also check equipment capacity, power consumption, refrigerant type, efficiency ratings, pressure drops, and compatibility with control systems. It is important not to select equipment only by capacity. The system must match the building's operational needs. I also review manufacturer data sheets and ensure the selected equipment complies with local codes, standards, and client requirements. 8. What is preventative maintenance in HVAC? Preventative maintenance means regularly inspecting, cleaning, testing, and servicing HVAC equipment to avoid breakdowns and maintain efficient operation. It includes cleaning or replacing filters, checking belts, inspecting coils, checking refrigerant pressure, lubricating moving parts, testing electrical connections, cleaning drain lines, checking pumps and fans, and verifying control settings. Preventative maintenance reduces unexpected failures, improves energy efficiency, extends equipment life, and maintains indoor comfort. I believe a proper maintenance schedule is much better than waiting for equipment to fail and then reacting under pressure. 9. How would you troubleshoot an HVAC system that is not cooling properly? First, I would check the basic conditions, such as thermostat settings, power supply, airflow, filters, and whether the fan is operating correctly. Then I would inspect the cooling coil, condenser, refrigerant pressure, valves, dampers, and control signals. Low cooling could be caused by dirty filters, blocked coils, low refrigerant, compressor problems, faulty sensors, poor airflow, or incorrect control settings. I would follow a systematic approach, avoid guessing, record readings, identify the root cause, and then recommend the correct repair or adjustment. 10. What is the role of filters in HVAC systems? Filters remove dust, dirt, pollen, and other airborne particles from the air before it passes through the HVAC system and enters occupied spaces. They help improve indoor air quality and protect equipment, such as coils, fans, and ducts from contamination. Dirty filters can reduce airflow, increase energy consumption, cause poor cooling, and even damage equipment. Filter selection depends on the application, required filtration level, airflow, and pressure drop. In healthcare or cleanroom applications, higher efficiency filters such as HEPA filters may be required. 11. What is a chiller and how does it work? A chiller is a machine used to remove heat from water and produce chilled water for air conditioning or process cooling. The chilled water is circulated through AHUs or FCUs, where it absorbs heat from indoor air. In a vapor compression chiller, the main components are compressor, condenser, expansion valve, and evaporator. The refrigerant absorbs heat in the evaporator and rejects it at the condenser. Chillers are commonly used in large buildings such as malls, hotels, hospitals, offices, and industrial facilities. 12. What is the difference between air-cooled and water-cooled chillers? An air-cooled chiller rejects heat directly to outdoor air using condenser fans, while a water-cooled chiller rejects heat through condenser water connected to a cooling tower. Air-cooled chillers are easier to install and need less water treatment, but they are usually less efficient in large applications. Water-cooled chillers are generally more efficient and suitable for large buildings, but they require cooling towers, pumps, water treatment, and more maintenance. The selection depends on project size, climate, water availability, efficiency targets, and budget. 13. What is a cooling tower? A cooling tower is used to reject heat from condenser water to the atmosphere. In a water-cooled chiller system, warm condenser water leaves the chiller and goes to the cooling tower. The cooling tower uses air and evaporation to reduce the water temperature before sending it back to the chiller. Cooling towers improve chiller efficiency, but they need proper maintenance, water treatment, cleaning, and monitoring to prevent scaling, corrosion, and biological growth. They are common in large commercial and industrial HVAC systems. 14. What is the importance of duct design in HVAC? Duct design is important because it controls how air is distributed throughout the building. Poor duct design can cause noise, air imbalance, high pressure loss, low airflow, energy waste, and uncomfortable spaces. A good duct design considers airflow quantity, velocity, pressure drop, space limitations, insulation, leakage control, and diffuser placement. Proper duct sizing ensures that each zone receives the correct amount of conditioned air. I also consider maintenance access and coordination with other services such as electrical, plumbing, and fire protection systems. 15. What is static pressure in HVAC? Static pressure is the resistance to airflow inside ductwork, filters, coils, dampers, and other HVAC components. It is an important measurement because fans must overcome this resistance to deliver the required airflow. If static pressure is too high, the system may have low airflow, higher energy consumption, noise issues, and reduced equipment performance. Causes can include dirty filters, blocked ducts, undersized ductwork, closed dampers, or clogged coils. Measuring static pressure helps diagnose airflow problems and verify whether the system is operating correctly. 16. What is VAV in HVAC? VAV stands for Variable Air Volume. It is an HVAC system that changes the amount of air supplied to a space based on cooling or heating demand. A VAV box controls airflow to each zone using a damper and sometimes a reheat coil. When the space needs less cooling, the airflow is reduced, which saves fan energy. VAV systems are common in office buildings because they provide zone control and better energy efficiency. Proper control settings and balancing are important for good performance. 17. What is the difference between VRF and split AC systems? A split AC system usually has one indoor unit connected to one outdoor unit and serves a limited area. A VRF system, or variable refrigerant flow system, can connect multiple indoor units to one or more outdoor units and control refrigerant flow based on each zone's demand. VRF systems offer better zoning, energy efficiency, and flexibility, especially in hotels, offices, and commercial buildings. However, they require careful design, proper refrigerant piping, skilled installation, and good control setup to operate efficiently and safely. 18. How do you ensure energy efficiency in HVAC systems? I ensure energy efficiency by selecting properly sized equipment, using high-efficiency chillers or units, optimizing airflow, reducing duct leakage, maintaining clean filters and coils, using variable speed drives, improving insulation, and applying smart control strategies. I also check temperature set points, operating schedules, fresh air quantity, and system balancing. Preventative maintenance is also important because dirty equipment consumes more energy. Energy efficiency should not reduce comfort or indoor air quality, so I focus on practical improvements that save energy while maintaining reliable performance. 19. What safety precautions do you follow while working on HVAC systems? Safety is very important in HVAC work. I always follow lockout and tagout procedures before working on electrical equipment. I use proper personal protective equipment, check refrigerant handling procedures, ensure good ventilation, and follow safe working practices when dealing with pressure systems, rotating parts, hot surfaces, and chemicals. For work at height, I use approved access equipment and fall protection. I also follow site safety rules and manufacturer instructions. Good safety habits protect workers, equipment, clients, and the overall project. 20. What are common causes of compressor failure? Common causes of compressor failure include low refrigerant charge, overcharging, dirty condenser coils, poor lubrication, electrical faults, overheating, liquid refrigerant returning to the compressor, blocked filters, poor airflow, and incorrect operating conditions. Compressor failure is often a result of another system problem, not just the compressor itself. That is why I believe it is important to find the root cause before replacing a compressor. Otherwise, the new compressor may fail again. Regular maintenance and proper system monitoring help prevent compressor damage. 21. How do you handle complaints about uneven cooling in a building? First, I would listen carefully to the complaint and identify which areas are affected and when the problem occurs. Then I would check thermostat settings, airflow, diffusers, dampers, filters, duct condition, insulation, and system balancing. Uneven cooling can be caused by poor air distribution, blocked ducts, incorrect zoning, solar heat gain, faulty controls, or undersized equipment. I would take measurements such as room temperature and airflow, compare them with design values, and then recommend corrections, such as balancing, control adjustment, cleaning, or design modification. 22. What is HVAC commissioning? HVAC commissioning is the process of testing and verifying that HVAC systems are installed and operating according to design requirements, project specifications, and client expectations. It includes checking equipment installation, airflow, water flow, controls, sensors, safety devices, balancing reports, and performance tests. Commissioning helps identify problems before handover and ensures the system performs properly from the beginning. It also provides documentation for operation and maintenance teams. A well-commissioned system improves comfort, efficiency, reliability, and customer satisfaction. 23. How do you coordinate HVAC work with other trades? HVAC systems must be coordinated with electrical, plumbing, fire protection, civil, architectural, and structural teams. I coordinate by reviewing drawings, attending site meetings, checking ceiling spaces, confirming equipment locations, and resolving clashes before installation. For example, duct routes must not conflict with cable trays, pipes, beams, or fire systems. Clear communication is very important because poor coordination can cause delays, rework, and extra cost. I believe early coordination, updated drawings, and regular site inspections are the best way to avoid major problems. 24. What is BMS in HVAC? BMS stands for Building Management System. It is used to monitor and control building systems, including HVAC equipment such as chillers, pumps, AHUS, FCUS, fans, dampers, valves, and sensors. Through BMS, operators can view temperatures, pressures, alarms, schedules, and equipment status. A good BMS improves energy efficiency, comfort, maintenance planning, and fault detection. For example, it can automatically adjust set points, control fresh air, or shut down equipment during unoccupied hours. HVAC engineers should understand BMS logic and control sequences. 25. Why should we hire you as an HVAC engineer? You should hire me because I bring a strong combination of technical knowledge, practical troubleshooting ability, safety awareness, and teamwork. I understand HVAC design, maintenance, equipment operation, energy efficiency, and site coordination. I do not just look at one component. I try to understand the complete system and find the real cause of problems. I am also willing to learn, follow standards, communicate clearly, and take responsibility for my work. My goal is to help your organization maintain reliable, efficient, and comfortable HVAC systems. HVAC engineer interviews are not only about theory. Employers want to see that you can apply your knowledge in real situations, solve problems calmly, work safely, and communicate with different teams. Before your interview, review HVAC basics such as cooling load, chillers, AHUS, FCUS, duct design, ventilation, controls, preventative maintenance, and energy efficiency. Practice your answers in a clear and confident way, using examples from your own experience whenever possible. A strong HVAC engineer is technical, practical, safety-focused, and reliable. With preparation, you can give professional answers and make a strong impression.